Okay, so today we have our math history overview over um, China, India, the Islamic, and the medieval periods. We will start with Chinese mathematics. So we don't see a lot of overlap between the Chinese mathematics and other civilizations because they were off on their own a lot and not in very much contact with the West. But we do see them being the first civilization to introduce a base 10 number system, and we see their stuff going back very early. Um, Previous like going at the same time as some of the stuff we were looking at with the Babylonians and with the Egyptians, but we start to see their stuff coming around the second millennium BC and really start to get solidified and organized around that time. And we see that they held mathematics very important as they had their people working in the government needed to have a certain knowledge of mathematics. We see a big influential work in their culture was Lee Hughes' Sea Island Mathematical Manual, which had many problems, like the famous Sea Island problem, where they're trying to measure a peak and they put up different poles to gauge the distance and use triangles and geometry to figure out how tall the island was. And we see early work with geometry and Pythagorean theorem using that problem. And we also see them using the double box lid to find the volume of a sphere and volumes of other things, and taking the cross sections that are contained within the box to find the volume of the sphere. Now, moving on to Indian mathematics, we start to see an intersection because they were in a little bit of contact with the West, and as we will get to later, contact with the Muslims and how that all came about. So we see that Alexander the Great invaded them in the 3rd century BC, bringing with some Greek material and allowing the Indians to be in contact with that and gain an interest in that. We start to see mathematics and mathematical interest being evidenced as early as the 2nd century BC. And because of this Greek influence, trigonometry gained popularity in India. They had these texts like the elements and all these things to be able to start becoming curious and trying to figure out what this all means and if these things are true. And we see a united Indian culture by 400 AD, and that's helping bring in all of this mathematical curiosity to be able to, for people to come together and work together to figure out what is true about mathematics. And they were in contact with also the West and also China, because they were kind of in a nice middle spot for there. So we see that they adapted and created the zero. China had a dot, but we had not yet seen a zero in play. But the Indians were able to create that zero that we so greatly value today. Moving on to Islamic mathematics, we see the rise of the Muslim people and the Islamic religion coming after Muhammad and his vision, and it grows greatly in popularity in the region and amassing tons of people, tons of allegiance as they work to go capture the Mecca. And they do. And this is becoming a great world power because they're just moving so fast and going everywhere. And we start to see them go into the West, going into Europe as they conquered Spain in the 8th century, which put them in constant contact with the Western world, which is great for us because then we get to see the advances of what they had from the Indian cultures, from the Greeks, because they were in a ground where they're getting all of these different sources and inputs into their mathematical thinking. So we see all of their ideas start to become Western ideas and exchanging those things. Baghdad became the capital soon after its inception, and it became a influential intellectual center, kind of like how Alexandria was for the Greeks. Now we see Baghdad starting to amass this interest in this bringing together of minds and of intellectuals and of logic and philosophy and all these things being discussed there. And we see sort of in the mathematical realm, they're building on decimal arithmetic greatly from the Indians. We start to see that work with them. And it's moving into Islamics, and they are just building on it. And we see this trend of a lot of things already being conceived either by the Greeks or by the Indians or by these previous cultures. And we're seeing just being built on and further refined and shown to be true, is with the Islamics, as we'll see in the medieval periods. We've even seen with the Indians as well. And then we have algebra. The birth of our modern algebra dates to an 825 work by Al-Khwarizmi. And it was basically just a manual for problem solving. A lot of works with quadratics and more theoretical things than just problem solving instead of mathematics for trade or for government work, but understanding what is true about these things and how they work. And we see a lot of different forms of quadratics, and like we have today, because they did not yet work with negative solutions. That was not something they were considered or worried about, so they just didn't work with them. So we have, when you look at quadratics from these works by the Islamic people, you just don't see negative solutions. So it gives us a lot of different solution methods. A little bit more, we see that they built on the Greek work. The Islamic people were very interested in Greek scholarship, and we don't really think of Islamic people as being very interested in scholarship, but they were very interested in Greek mathematics early on. And this is shown in their geometry, which is heavily influenced by Euclid. And we just see their fascination to try and refine these things and figure them out. See how Samuel, born in Baghdad in the 12th century, he brought great understanding of decimals. He was one of the first minds, and we see this continued through the West and through the Islamic mathematic development to understand what decimals were. And you could see that there was the numbers that were whole, and then after the decimals, we could see as a part of a 10 and then a hundreds place, and we see these place values being assigned with Al-Samuel's work. See Al-Qaimi did lots of work with cubics. Again, a lot of very interesting methods because they, again, did not work with negative solutions. So we see this work being done in a lot of different ways because they just don't have the ability to do these things. And again, we're seeing the bringing together of all these previous mathematics from Greek and Indian and Egyptian cultures even, and they're growing into less practical mathematics, growing away from just the ones that are concerned with trade and government. We're seeing them wanting to just be curious and figuring out what is true and how to prove these things to be true. And we see the Islamic State start to decline by the 15th century, a perfect time for the Western and the East, or the Western world in Europe to pick mathematics back up and start to make their own developments based on Islamic ideas and theories, because they were in contact through their conquering of Spain. Then moving on to our final one of medieval mathematics. There's not a lot of ability and a lot of financial freedom to be moving around and just to study. So we see a lot of the progress and learning coming from monasteries and people who aren't doing a whole lot else besides devoting their life to learning or to spiritual things. We are also seeing weaker governments moving from tax-based to land-based systems. Could be evident or promoting more interest in geography as we start to get into times where learning is picking back up and we're growing to become more interested in intellectual things. We see that Spain would take Greek and Muslim works. This is a great thing for the growth of the West. We see Spain taking the Greek and Muslim works from Arabic to Spanish, and then from Spanish to Latin, which was a scholarly language at the time and the generally spoken language that people would be using to learn. So that was a great thing to be able to take these older works and be able to evaluate them and further build on them, as we see has been done today. Then we have a few people, Abraham Barhaya, which we have right here, his proof of a circle, basically cutting it up into little circles and then laying them out to show how it is similar to a triangle and how that area comes about and how we're able to calculate that. And we also have Abraham Ibn Ezra, who proved 1 squared is equal to 1 cubed, which we know that to be true. So thank you, Abraham, for proving that for us. And then to wrap things up, we have Fibonacci, who comes in a little bit later, and he's popularizing the Arabic number system, as long as with many other things. But it's great to have that because that is the number system we use today.